Hello, sports fans, and welcome to the Great Race. Thanks for tuning into this epic sports event between two finely trained runners. At the top, Priscilla Primo is teeing off against Scotty Segundo on the bottom. And the two of them are going to be racing in a few events here, so we're going to warm them up with just a short race. So this is a 5-meter race. When you hear the whistle blow, they're going to start. And in that warm-up race, it looks like Priscilla got him. Possibly a false start there, Priscilla, so be careful. But that was just a warm-up. So now we're going to up the race distance each time. So here's a 10-meter race. And up, wow, Priscilla's quick out of the start. Scotty a little slower, so he's gonna be behind again, but maybe he's just warming up. Maybe his race is a longer distance one. So we're gonna be doing a 20-meter race over here. This time I'm actually going to be timing it. So I'm gonna hold up my stopwatch to the screen for this one. Okay, so it looks like Priscilla came in there around 4 seconds. Scotty closer to 8 over there. So we're going to be talking about lag time because we are going to be relating this to earthquake waves. So the lag time for this event was about 4 seconds. Priscilla came in around 4, Scotty came in around 8, and that's going to be important. We're going to do that for all of them. So it looks like Scotty's race was not that either. We're going to give him a longer distance race on that. Now we got some real distance here for Scotty to show his stuff. 100-meter race. Are you all ready? Let's begin. There goes Priscilla, somewhere around 5. Scotty's still trailing. Looks like somewhere maybe around 11 or so. So 10 or 11. So in this case, Scotty came in about 6 seconds or so after Priscilla rather than about 4. So he's still trailing here. Okay, we're gonna now go to the 400-meter race. And on the bottom there, for my purposes of my animation, I had to make Scotty an S and Priscilla a P over there. All right, ready? So Priscilla taking a commanding lead here. Racing around the track at lightning speed. She's about to come in. It's like somewhere around 17 seconds. The crowd is turned on Scotty. I think that's wrong. But they're booing poor Scotty. He's still taking some time to get in here. We're at the 30-second mark. He's still not in. Almost. Scotty, get there. Around maybe 35 or so, 36 seconds. All right, so in this case, Priscilla was around 17 seconds in, and Scotty was around 35, 36. So now we had a longer race. We actually have a longer lag time. So we have 18-second, 19-second lag time for this one. So as you can see, the longer the race, the more distance that Priscilla has to use her speed to get ahead of Scotty. So Scotty's looking worse and worse in each of these successive races. So we're going to go to a consolation race for Scotty. All right, we're going to make it be 2 meters only, all right? Ready, set, go. All right, so I didn't bother timing it there. I don't know if I could have even. Scotty looks like he's doing okay in that race, right? So we have such a short race here, a ridiculously short race. Scotty doesn't even appear slow, right? There's barely a lag time between the two. So we're going to now relate this to actually earthquake waves. So we're going to be thinking about this question. Well, what's the relationship between the distance of the race and the lag time between Priscilla and Scotty? And I explained that to you before, right? So the greater the distance of the race, the longer the lag time. Priscilla can use her blazing speed to get farther and farther ahead of Scotty when she has more distance to do so. When it's a short race, she doesn't have that distance to really get ahead. So now, this is the idea here. Well, even if we didn't know the distance of the race I was giving you, we could make an inference of how far they ran by how much longer it took Scotty to come in for Priscilla, right? If it was like a minute difference between them, we would know that would be a much bigger race than a 400 meter race even, right? So we're going to now relate this to our earthquake waves. So now if an earthquake occurs in San Francisco, all the way over here, and we have a seismograph station in New York over here, there's going to be a pretty long lag time. Now hopefully by now you've gotten the point that Priscilla Primo is the P wave, the first wave that arrives at a seismograph station, and Scotty Segundo is the S wave. So 2,500 miles between New York, where we are, and San Francisco is going to be enough for Priscilla to get ahead. So let's watch what happens here. So there's the earthquake, and there's the release of the P waves and the S waves. They both get released at the same time. That's important to know. But the P wave is going to arrive first, and it was a long distance, so Priscilla, or the P wave, got in there much farther ahead. Let's do a race from Boston to New York. So same seismograph recording station in New York, but we're a lot closer here in Boston. So as you would imagine, right, if we have a race here, we have an earthquake, they both start at the same time. There's our P wave, and then Scotty, or the S wave, comes in shortly thereafter. There's not as much of a lag time or difference between the two waves in this case. Now, of course, if the earthquake's in New York itself, there would be no lag time at all because the starting line is the finish line, right? There is no distance there for Priscilla or the P wave to get ahead. So they're already there. So this is important. This is a really critical thing about how scientists can figure out how far away an earthquake is from their recording station by using these lag time information they're going to get on their seismograph readings. So now this is what the readings look like on a seismograph. So we have our time is going to be on the x-axis here. We have the P wave always arriving first, but the P wave is not as strong as the S wave. So that's why scientists know when the S wave has arrived, because the waves, the amplitude of the waves are bigger. They do more shaking. The P wave does less shaking, and of a different type, if you remember. So the P wave came in here, the S wave came in here, and our lag time is going to be, of course, the difference between the two. So now here's a question for you to see if you get the hang of this. Which seismograph station was closest to the epicenter? We have station 1 over here, station 2, station 3, and station 4. So which one was closest to the epicenter and which was farthest away? So our lag time is going to, again, be the difference between when the P wave arrived and the S wave arrived. And in this question, those dashed lines are helping you figure this out. So let's go closest to the epicenter first. Give you a moment to think. So closest is going to be the shortest lag time or the greatest lag time? Well, you got to think back to the race, right? If the race was short, there wasn't much of a running race for Priscilla and Scotty to do. Scotty didn't fall that far behind. So we are going to be number 2 over here. That's the shortest difference between Scotty and Priscilla. And then, of course, the farthest away from the epicenter that this seismograph station in has to be the biggest lag time, like that last race I showed you, where Scotty really miserably fell behind. So the farthest away is going to have to be a situation where the longest lag time exists. If you remember from the last race, Scotty was miserably behind Priscilla in it because it was such a long distance. Priscilla was able to get much farther ahead. So obviously we're looking for the biggest gap here, which is going to be number 3, because you have a bigger lag time here. And you could probably figure out here, this lag time is about 5 minutes, maybe 40 seconds, because here's our 10-minute arrival time for the P wave, 15, maybe 40 for the S wave. Whereas when we did the shortest one over here, right, the difference between the two was maybe a little less than 2 minutes. We have about 10 minutes, maybe 15 seconds, and about 11:55. So we're going to be doing this more and more as we continue in our earthquake unit. Well, thanks for joining us for the Great Race, and I hope you do well in your studies and hope this helps you understand it. Bye.